Thanks to everyone for joining us. And thanks for your interest in serverless development and hosting. We've got incredible content today, a lot of presenters with who have put in a ton of work, super smart stuff that they're going to show you. And I think you're going to be inspired, and I think you'll find this really beneficial. We're planning to go somewhere between 45 minutes to an hour. And I think by the time we get through this, you're going to have a good understanding of the serverless platform and how it's going to help your development efficiency. The Promevo team has some specific examples of tools that we've built using the serverless platform that we're going to show you. But we also have a lot of VIPs from Google who are directly involved in the management of the serverless suite. So you're going to hear from both of those teams today. Quick note on Promevo, who we are. We are a Google-centric sell, service, and build partner, which means we help companies with the entire Google Cloud ecosystem, from cloud to Chrome, workspace. That means we help manage your devices, your GCP. We also offer gPanel, which is our proprietary Google Workspace user management, automation, and reporting platform. Specifically for today's conversation, we have a team of specialists who are cloud certified architects who work in these platforms every day. They build things for clients. They help clients strategize. They do a lot of educating, a lot of building. So if that is of interest to you, then reach out. Whether you're a builder, whether you're just getting started or trying to learn, and you just want to punt an entire project over to us, Promevo does all of those things, whether it's with you or for you. So this is who you're going to meet today, our presenters. From Promevo, we have Justin and Aaron. And on the Google side, we're joined by Chandi, Carolina, Brandon, and Daniel.
Yeah, hello everyone. My name is Brandon Velasquez, and I'm a customer here with Google Cloud. And I wanted to briefly just talk about your Google Cloud team and how we support our customers. So most engagements with customers typically start with the sales rep. They lead account strategy, they handle pricing, and just to ensure that you guys have an overall great experience. They typically introduce customer engineers to help more of the technical side of things, and then make sure to keep customer engineers as well as product team and partners invested in your company's success. As a customer engineer, I personally drive a lot of the pre-sales technical activities, such as architecture reviews, kind of doing demos and stuff around that. I support existing workloads just to get general advice on product recommendations and how to cost optimize, as well as remove technical blockers. And we have an excellent suite of partners, Promevo specifically, we're talking about today, that are responsible for the implementation. So they drive migrations and help to have success in migrating workloads, as well as delivering solutions that help you with your business. They also collaborate with our sales teams and our customers and engineers to just ensure that we have clear channels of support. And then finally, the product team, they help engage with customers to understand your demands and needs, find room for improvement in our Google Cloud services, as well as serve as the voice of the customer internally within Google Cloud.
All right. I'm Justin Baroni. I'm a principal architect here at Promevo. Build a lot of solutions, a lot of serverless solutions. So what I'm going to start off here and talk about is a kind of a customer case study of a scenario where we took a client that was in another cloud, kind of partially in Google a little bit. They had their database running in Google, and how we migrated them over and went fully serverless with them using Cloud Run. So this customer, I'm just going to walk through kind of, this is the before, right? So we have a customer that wanted to move their API to the cloud. As you can see on the left, they were in another cloud in the East Coast. They had an Ubuntu VM. They had to deal with a lot of issues when it came to updating, as far as pushing releases to their VM, as far as dealing with scaling and whatnot. So it was actually a really simple architecture here. It was just running an Express.js REST API. They were probably doing about 10 requests a second. They supported a total of 100,000 users. That doesn't mean there were 100,000 users using this system at the same time, but their front end used this API for basically all communication between the database for reads and writes. The reason they reached out was because they were planning and anticipating growing up to 1 million users that they needed to support. And they thought, okay, maybe we're going to hit 100, 150, 200 requests a second. And right now with what they had, they were like, oh, this is, way too hard to deal with. And I'll go into sort of a little bit of the details there. Their DB was a medium-sized Mongo Atlas. It was a replicated cluster deployed over in GCP. So it was purchased through Mongo Atlas. Everything was done there. But when you deploy out a cluster in Mongo Atlas, you can choose to deploy it out to various clouds. Theirs was out in GCP, and that's the significance there is going to be important here in a little bit when I talk through some of the money that we've kind of saved them. Access to Mongo was over the public internet with whitelisting. So I don't know if there's any DBAs out there listening. One thing I always see as sort of a red flag and kind of worries me a little bit is if the database, even though you're doing whitelisting of IPs, is still available public to the internet. Some other things to note here on the API server, they were running a single VM, a single Ubuntu VM. Internal to the server, they had Nginx running as a proxy and a load balancer. And then they had multiple instances of their node server running using systemd. So the fear here is that if this VM dies, their entire application goes down, right? It's not, if we were to think prior to Docker or prior to containerization, you would have maybe had the Nginx server as its own server. You would have, its own VM. You would have had multiple node VMs where you had instances of node running on them. And then you could scale up VMs and scale down VMs and things like that. This wasn't that scenario. This was done for kind of performance reasons. So they weren't using Docker. There was no PM2 to manage their node server or anything like that. So the other thing I want to point out too is, in a situation where they had failures with their server, their only option was really like recovery from a backup and restore from a backup. So, they could have downtimes of, 15, 20, 30 minutes if, they even just restored right away. So they were definitely outgrown what was, a very early production architecture, right? I could see early on when they barely had any traffic, they're like, hey, this will work. But they kind of outgrew that. And they got to this point where they were really nervous and frustrated. App deployment. So if you can see here, their deployment machine, they literally, when they would deploy their app out to the server, they would just use SCP and just push a zip up. So they would take their build, they'd run it, they'd zip it up, and then push it up to the server into a location. Then they would SSH into the server, expand out the zip into a directory, and then restart all the instances one by one. So one of the things I like to always point out whenever you're looking at any kind of architecture, what have you, is like when people are the ones doing different steps of a deployment, of any kind of management of a server, that just screams human error, right? Because we're humans, we're not computers. We don't perfectly execute every operation. Maybe, the person whose job was to deploy was tired that day. You never know. And they miss a step, right? Whenever that kind of happens, you fall into some traps. Another thing I want to point out, scaling here was vertical, right? So if they were like, oh, we're hitting our peak, we're maxing out our CPU, our memory, they were just giving it the next size up VM and the next size up VM. And they weren't really scaling down until they, were in like off season. So what would happen is they'd be burning money in parts of either the day or parts of the year even, or month, where they had very little traffic. And then, they're paying for this big expensive VM and their CPU's running at like 0.5% usage or something. They had to, one of the other things, right? When you got a VM, you got to you're on the hook for managing the OS, for making sure there's security updates, installing packages, making sure the packages are all updated. So really, this is sort of like last gen kind of way that you would run some server systems. Deployments, and this is one thing I want to kind of point out here and just kind of remember this, deployments took upwards of 2 to 3 hours. And that was because they would deploy, they would run tests, they would verify. Sometimes they'd have to roll back, like 2 hours, 1 hour, maybe 1 hour if they were like lucky and it was a real simple deploy. But they tend to spend a long time deploying and validating that, hey, this next version of their API, right, is good. And then sort of one of the other things I wanted to point out here, and the reason why I brought up why it matters that they were in GCP is that, they were paying a lot of money in egress every month. So, with cloud, with really anywhere where you're in a data center, anywhere where you're sending data out from the server, the data you're paying for that, and that's considered egress, right? So from their MongoDB data transfer, they were spending 12.5 cents a gig. So that was considered an external IP, and it was a Google Cloud to the public internet egress. That's kind of the most money you can spend on egress, right? Then from their front end server, they were spending 9 cents a gig. And so if you can put that together, they were spending around 21.5 cents a gig. And when that might not seem bad if you're doing 10 gigs a month or something like that. But when you're pushing hundreds of terabytes of egress a month, that starts to add up big time. So what was our solution, right? First thing, we knew we could set up a peering connection between MongoDB Atlas and a Google Cloud VPC. So they were in some other cloud, right? And we were like, okay, first thing we can do is if we get them into GCP and have them running out of the same region, then we can save some money there, right? Next, and then the other thing about that as well is the privacy, right? Now their database isn't going to be exposed publicly to the internet. It's going to be on a VPC effectively in its own internal network or subnet and not accessible via the outside world, which is very important for hacking and security and what have you. So next we had to decide where the application would run. So one of the things I love to do, and there's this really great page over at Google Cloud, and feel free to snap a shot of that QR code and head over there and check this out. This is a really great page that kind of shows you like options for where you want to host things. And I'm showing just a very small snippet of this table that they have, where on the right you have cloud functions, on the left you have your VM. And kind of the way I think of it is if you go from right to left, you're going from more agile to more configurable, right? So when you go serverless, you're much more agile, right? Because you're just focused on writing your app code, pushing your app code, right? You're dealing with your application. Your devs can like fully focus on making your users and your customers happy. When you go to VMs, right, you get way more configurability, and you may need that for your application, but you're going to, there's much more maintenance involved, right? Keeping the operating system up to date, keeping security patches in place, blah, 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 right? So the way I always try and look at things is I really want to think about how can I go as serverless or as agile as possible when I'm scaling out a solution. So I just wanted to kind of show this and give you an idea of just sort of what I look at when I put something like this together. So what did we come up with for them? All right. So the solution, we Dockerized and migrated them to Cloud Run. So we took their Node API, we Dockerized it, right? We built a CI/CD pipeline in GitLab for deployment and containerization. So they were working out of GitLab as their source control repository. Well, now, remember before there was this whole process of, all right, I'm a developer. I'm going to zip up the build. I'm going to do the build. I'm going to zip it up. I'm going to transfer it up to the server. Then I'm going to log into the server and I'm going to do all this stuff. Well, what they have now with a good CI/CD setup is they deploy based off of merges and branching and tagging. So they can give a specific tag and a specific branch and merge into that. And what it does is it deploys out to either their production environment or their test environment, their beta environment, what have you. So it's really cool. So as a developer, I can just do my work, push it up, get all my code reviews, get all our testing and stuff done. And then our merge manager can go ahead and schedule it up, merge it into the correct branch, and away it goes. So the beauty of this is it takes that code, it runs it through Cloud Build. So it runs a build and it creates a Docker image. It then pushes that image to Artifact Registry. Cloud Run picks that up, and because there's some code in there that kind of handles transferring over to the new version, it's called traffic splitting, and we use that. And what happens is when they do a deploy, within a few minutes, their stuff's out there and live, and it's a really great setup. Additional to that, we create a Cloud Run service, right? So that service that their app is running on that REST API, where that Docker container is running, it's Cloud Run. We protected it by using Cloud Armor and a global load balancer. I didn't show that here just for lack of space, but some of the great stuff out there that Google Cloud has for just security, right? Security first, and just thinking from that standpoint. Their database solution stayed exactly the same. So that's kind of the beauty here. They had this very large database, many terabytes of data. And all we had to do was we created a VPC peering connection between Mongo Atlas and their client VPC. So we effectively created this connection directly from where their database was being hosted in a VPC that was controlled and managed by Mongo Atlas, but it was within the same region. So now their transfer costs went from, their egress went from, what did I say, was 12.5 cents to 1 cent per gig. So now it was considered an internal IP zone to zone egress in the same region. So that's really significant right there, right? And then based on the amount of data that they pushed out of the system, their public internet egress from their Cloud Run instance out to the public was about 4.5 cents. So we brought them down to about 5.5 cents per gig, and that's about a 75% reduction in data transfer, which is really awesome, right? Some ROI right there. In addition, we use some like really cool features of Google Cloud, right? Like I talked about Cloud Armor, I talked about the load balancer. We also use Secret Manager. So Secret Manager plus some environment variables. So any of those configuration settings, any secrets like API keys for talking to other REST APIs, some third-party APIs, the keys for talking to the database, all those were kept in Secret Manager and injected into the Cloud Run instance when it fires up, and then the application just picks it up and reads it as it's utilizing it. So really, really smart way to do security there. We then, when we deployed this out, one of the things I wanted to kind of talk about was how we tuned Cloud Run. So Cloud Run allows you to run multiple, to take a container, kind of push it out, have it run as a service, and then it'll scale on demand. It'll scale up, it'll scale down, and there's some things you have to do there to make sure that your application's scaling correctly. So you'd set your min and your max instances. They wanted to be able to start from 0 instances, and so if you set that at 0, your application has to be able to start up very fast. So that was some things where we had to do some sort of tweaks to their application to just make sure it starts up quick. You mess with the memory, like how much memory do you want to be able to give this? We had to increase memory because we were doing some PDF generation in one of the APIs. And then you also set how many concurrent requests you want. So it's kind of across all those different variables, you can determine how it scales up or down. And then the other thing that we did was, as we were testing the system out, whether it was in the beta environment or when we went to production, we would monitor peak times and then sort of tune according to that, according to, how we wanted it to scale and sort of that curve. I always try and set it up to where from a memory and CPU standpoint, I keep it at about 80-85% of memory and CPU. It gives it a little overhead for bursting, but it's kind of using as much as it can. And then, the other thing I kind of wanted to point out here is like they're now doing fully automated deployments, right? I talked about before how whenever they needed to scale because, say, they were running into, issues and running out of memory or CPU, they were having to spend a lot of time and it was very stressful. Now that all happens automatic. This is like the beauty of Cloud Run. If anything that you can take away from that is the on-demand, the scaling, and kind of being able to work in your CI/CD process into this is awesome. So the customer could actually focus on app development instead of stressing over scaling, right? And then lastly, I just want to quickly go through the kind of benefit they got from this, right? So beforehand, they were peaking at around 10 requests a second. It was very painful. Everything was manual, deploys, scaling. There was too much human interaction, chances to for things to fall apart. Big egress costs, big server costs, wasted server costs. Their DB, even though it was whitelisted to an IP address, it was also open to the public internet. 2 to 3 hours to test and deploy. Deployments required a maintenance window. They had a 22% deployment failure rate, a lot of human error. No monitoring, alerting, or metrics, zero redundancy, and their scaling during peak season was a nightmare, right? And had everyone stressed out. So what did they end up at? They grew to 100 requests a second. No intervention. In fact, I talked with the client recently and they said, like, hey, we don't even have to touch it. We just worry about pushing updates and working on the application. The infrastructure is great. It scales up and down as expected, and they never have to worry about it. They now have a CI/CD deployment process. They saved 75% on their egress. Their database is more secure, right? Because now it runs in a private network. Dynamically, they can scale from 0. They have faster, more consistent performance because now they're running internally on the GCP premium network. CI/CD and tests. This is the biggest thing right here. Their deploy is less than 4 minutes. So that 2 to 3 hour deployment time is now 4 minutes. This is amazing. Their only bottleneck is running their automated tests and their Docker build. No more maintenance windows. They can deploy multiple times a day. Thank you to traffic splitting. I mean, they could deploy 100 times a day. It wouldn't matter. And this is kind of the beauty of going to Cloud Run, going to serverless, is that they have an entire pipeline and they can do on-demand deploys. This is great, right? They have a 1% still deployment failure rate, but that's human error, right? Tests are failing, this or that happens, right? That's still going to happen. You kind of can't get away from some of those things, but because of traffic splitting, they don't, the customers don't see that failure. And because of they have a really robust beta environment and test environment. So their ROI, they achieved 98% reduction in deployment time, 95% decrease in failure rate. And so their total efficiency gain was 97%. And then my favorite part, their DevOps had a satisfaction of 100%. They went from wanting to pull their hair out and being really freaked out all the time whenever they had to deploy updates, deploy anything, to they're loving it. So with that, I just wanted to go through that. I know that was a lot of stuff. You guys will be able to get a hold of this video and run through that and see this. And again, if you need any help from us setting this up, please hit us up. So now I'm going to hand this over to Carolina, and she's going to talk about Cloud Run in a little more depth.
All right. Hi, my name is Carolina Netolitzka, and I'm one of the product managers working on Cloud Run at Google. And today I want to explain to you all about Cloud Run and hopefully convince you why it's a good environment to run your application or build your next application. So companies of all sizes today are moving to the cloud, but many run into challenges. Some of those challenges come from the sheer complexity of running your application in this new environment that you probably didn't learn in college and may not have encountered before. And cloud products have gotten better over the years, but as they've gotten better, they've also gotten more complex. And this can lead you to not have the velocity that you hoped you would have for moving to cloud. And optimizing costs can become its own exercise in operational management if you're using things like virtual machines and self-hosting databases and things like that. So the Cloud Run team looked at these challenges, and we designed our product as a way to help you overcome these challenges. So Cloud Run is a serverless product. What we mean by serverless is basically fully managed. It's you give us your container, we provision the infrastructure for you, we run it for you, and we make it easy for you to do day 2, day 3, and so forth operations. So kind of 3 big tenets of how we think about designing Cloud Run and its functionality are: Cloud Run is simple and automated. So when we build new features, we really optimize for how do we make developers as productive as possible with this. We make sure Cloud Run is secure. And of course, not just it's secure, but it's easy for you to manage the security and feel confident that your application is properly secured. And third, versatile. So a great platform is no good if it only does 1 or 2 things. So we want to make sure that you can run as many parts of your application as possible on Cloud Run. So I'm going to go over each of these 3 things: simple, secure, versatile. Simplicity. So if you've ever worked with Kubernetes, you've probably seen that there's a lot of different nouns to learn, a lot of different controllers and so forth. In Cloud Run, we have 2 things, 2 main resources: services and jobs. And these correspond pretty directly to things that you actually think about and want to run. So a Cloud Run service is something that runs indefinitely, and it's waiting for work to come to it. So this is typically a website, an API backend, maybe a mobile backend. And a Cloud Run service is automatically scaled. It comes out of the box with a URL. It's got built-in traffic splitting for gradual rollouts and rollbacks, can be triggered by all sorts of different networking protocols. And you pay either per request or per instance lifetime. So if your Cloud Run service is not doing any work, you are not paying for it. And the other type of resource we have is a Cloud Run job. And jobs are for essentially scripts or data processing jobs. Things where you start it, you run it, and at some point the container exits because it has finished what it was supposed to do. And jobs can run for up to 24 hours. There is no request-based anything, so they don't have to be a web server. Jobs can run multiple tasks in parallel, so multiple copies of the container can be executing in parallel and handling each a subset of the input data. And there's many ways to trigger them. You can execute jobs manually or run them on a schedule or as part of a cloud workflow. And you, again, pay only when the job is actually running. So instead of talking more, I'm going to give you a quick demo. I'm going to show you what Cloud Run looks like. So switching over here, this is the welcome console of Google Cloud. And I'm going to look for Cloud Run. And here we are. And I'm going to, so you have services and jobs. I'm going to create a new service. Let's use our sample container and let's call it like Hello World. And I'm going to allow unauthenticated invocations because this is a website. So it's a public website, no need for authentication. So let's create our new service. So what Cloud Run's doing right now, it's taking that container that I gave it. That was just a sample container, but you could put in, any of your container that you have. And Cloud Run created a URL here for us, which is a load balanced, globally available URL. where if I click on it, yay, that's our sample container showing that our new Cloud Run service is running. So just like that, that's all it took for me to deploy a container and have it available over the network to anybody. I deployed a second revision. I'm going to deploy another one. So now I have 3 versions of my code running, and I get to control how much traffic goes to each version so that I can roll out things gradually. And I have logs built in right here, so I can see all the requests to my application. And let's look at those metrics. I can see right here on my Cloud Run page how many requests my application has gotten, how many instances. So at some point it scaled to 5 instances because of the requests I sent it. Its CPU utilization, how much container time I'm being billed for, memory utilization, and so forth. So you can easily see what's going on with your application all in one place. You can also set up networking, connect to a VPC network, set it up so that the service is internal only. You can also set up a binary authorization or set up your service to require authentication. And you can set up different kinds of triggers, for example, event arc. I can also create a job, which is a similar kind of interface. Let's execute this job immediately, and let's ask it to execute 100 tasks. So let's say that I have a big database migration that I need to do, and it's going to, I want to get it done as quickly as possible. And so I do it in 100 parallel tasks. And Cloud Run right now is starting 100 copies of this container. And just like that, 3 of them have already completed. And now this container only just waits for 5 seconds and then exits. So it's not doing a whole lot, but you can see how quickly Cloud Run is able to scale out and start up containers. And then when they finish, you go back to having no resources running and your bill is 0 while you have no resources running. So let's go back to the slides. So I hope that I was able to show you that Cloud Run is easy to get started with, easy to operate, and you only pay for what you use. So let's talk about security for a little bit. With security, you actually, fewer options is better, because the more things you have to configure, the easier it is to get something wrong. So when you use a fully managed product like Cloud Run, this sort of line of where your responsibility starts and the cloud provider's responsibility begins goes up. And so you have less to worry about. And so really with Cloud Run, what you worry about security-wise is your source to prod pipeline, including everything that's in your container, and access control to the running application. And Cloud Run gives you simple and powerful security features for both of those things. You can scan for vulnerabilities using Artifact Registry. These are actually other Google Cloud products, not Cloud Run, but Cloud Run integrates really well with these products. You can prevent software supply chain attacks with binary authorization, protect passwords using Secret Manager, and for access controls, we have ways to control access to your application, both based on the identity of the requester, as well as on network-based, like where on the network the request is coming from, also known as firewall rules. And finally, versatile. You want your product that you have built your application on to be able to handle lots of different types of workloads, right? So the top 3 use cases for Cloud Run are public websites and APIs, private services. These can be internal websites or microservices, and data processing, scheduled jobs or background processing, batch processing, and on-demand, like streaming and batch data processing. So public websites, how would you build a public website on Cloud Run? So here in the middle, we have Cloud Run, where we're running our application. For storage, you want to use one of our serverless storage systems. For example, the LOADB database, the Cloud SQL database, or Cloud Firestore. There are several other options as well. You can use Identity Platform for end user authentication and cloud storage. You can use Cloud CDN for static assets, and you can cache some of those in cloud storage. Now, you might find that your users are in several different regions. And so what you'd want to do in that case is use a globally replicated database, deploy your Cloud Run service in every region where you want to serve, and then put a global load balancer in front of all of that. And the great thing about this setup, there are two great things. One is there is nothing, all of the components here are serverless. But the second thing is there is no cost to running Cloud Run in an additional region if you don't have traffic there. So you can deploy to 15 regions, and if you only get traffic in 3 of them, those are the only regions where you'll pay for anything. Next, private services. We're going to talk about microservices here. You can set up Cloud Run to have internal ingress, so internal only. This means that nothing outside your VPC network can access your Cloud Run service. And you can use ILB to get IP address on your VPC network to get to Cloud Run. And this way you can set it up so that different Cloud Run services can talk to each other. And finally, data processing. So for batch data processing, we have Cloud Run jobs, which I briefly showed you. And you can set up Cloud Scheduler to easily get basically a cron job in the cloud. So if you deploy a Cloud Run job and then set it up to run, say, at midnight every night, you can basically have a cloud-based cron job. So to sum it all up, Cloud Run gives you higher velocity and productivity, higher reliability because serverless is redundant by default, and we basically become your SRE team, and lower cost because you only pay when your service is actually running. So some of our customers experience 95% faster deployments on Cloud Run than on legacy platforms, 98% fewer interruptions to service, and 15 to 50% cheaper than running on-prem. 75%, you can read, sorry. All this is to say that Cloud Run gives you a lot of operational advantage. It's much easier to keep your application running well year to year on Cloud Run than with other options. And that's it from me. And now we're going to hear a live demo from the Promevo team.
Hey everybody, my name is Aaron. On the Promevo side, my job is the practice director for business intelligence and data engineering. So what I wanted to talk to you guys a little bit about today was I just want to show a quick demo of how these technologies, these Cloud Run and serverless technologies integrate with the other parts of the business. So you may be wondering, I like what I'm seeing here, but I want to see how does this work together with some of the other parts of the Google ecosystem. Justin is actually going to fire up a little demo we made. So I'll pass the screen sharing on to him. Yeah, there we go.
All right, here we go. Okay. You can see that, right, Aaron?
Yeah, looks good.
All right. I'm going to go ahead and submit. So this is our electric car review system. It's a really great system to find out all the sentiment of how people feel about the different models of electric cars out there. And, one of the things we wanted to do for this demo was just make it very simple, because it's less about what this thing does and more about what it's doing behind the scenes, and what the benefits are of using different serverless technologies out there. So I'm going to go ahead and pop in a car and driver review on the.
Very good.
All right, we successfully submitted. You want to?
Yeah. So what we did here was built a little website that takes, these customer car review data, submits them to a form, and it also embeds a Looker dashboard. And I don't know how many of you on the call are familiar with the business intelligence side of the business, but Looker is Google's BI flagship product. This is where all of the analytics, charts, graphs, your standard BI functionality can be performed. And what we wanted to show here was the way the Cloud Run, Cloud Function, serverless tools interact within the pipeline of this process to getting data through from the customer all the way through the system into a deliverable, so you can see the output. What's actually happening here? Justin, do you want to toggle to the concept? What we did here, we wanted to show the process, kind of our thinking through steps. This is essentially just our back of the napkin illustration of how we got here. What are we doing to build this application? The left-hand side of the screen is a lot of the concepts that Justin touched on in his presentation earlier. A lot of the application hosting technology. The right side of the screen functions more on the new things you're seeing now, which is the integration with natural language processing and the Google Vertex AI tools, BigQuery for storing the data, and then Looker for publishing onto that React web page. If you flip back to the...
Can we go back to this?
Yeah, I just want to see if it showed up ever.
It did. It's there.
All right. Yeah, so this tool will give you a close to real time integration with users. When they submit their reviews, it'll take it and process it through that pipeline and give you a nice little visual of what's happening in terms of the car reviews. Yeah, so what we have here is a little bit more of a formalized version. I'll let Justin speak to the front part of the solution.
Yeah. So, you saw a little bit of this very similar kind of CI/CD process here. We have a development machine. We can deploy out to cloud build. Our container gets packaged up into an image. That image goes into artifact registry, and then it pushes the Cloud Run. Cloud Run is hosting the app, and that's can fully scale that up and down. So if we get 1 billion users or 1 billion requests in a month to our sweet car review website, then this thing's just going to scale up and down, no problem. Again, Caroline talked about Secret Manager. I talked about that earlier, right? We're pushing the API key into the front end and then also consuming it on the back end. We used a Cloud Function this time for as a REST API endpoint. Now, you might have just had that REST API endpoint inside of your Cloud Run in a back end sort of Express app for your Cloud Run. You can kind of do almost anything, and that's why we really wanted to kind of show some of this awesome functionality. So this is just a Cloud Function whose job is to receive the submission of that form, and then it takes it and publishes it to a pub sub topic.
Yep. And on the next slide, we'll show you exactly what's happening with that data. So the other Cloud Function in this equation is taking that data and processing the data. The review itself is submitted, parsed, cleaned, and then stored in BigQuery. So all the analytics are happening under the hood inside of the Cloud Function. That's one of the versatility of Cloud Functions. It's nice and lightweight, but it's super flexible and can handle a lot of intermediate steps that need to happen for that data to get from the user to your visualization. On the next slide, this is just a really quick snapshot of some of the things Cloud Functions can do. And I love them because they're very lightweight, they're versatile, they can handle many different tasks. In our application, they're actually serving, as Justin mentioned, the endpoint for Cloud Run. It's also the entry point for the data. In the bottom right, you can see that it handles that lightweight data transformation and ETL. So inside the Cloud Function, it's doing some data processing with the Vertex language model, takes the result, stores it in BigQuery, and then at the end of all that, it pushes out to Looker. So yes, Cloud Functions are, definitely going to be able to help you out in many different ways. So not only in terms of hosting websites, hosting platforms, but they hook everything together under the hood, to get through data from the front end all the way onto your Looker dashboard into your analytics team's hands.
Can I add something, Aaron?
Sure.
Another thing I wanted to add that's kind of really cool is I'm a front end React guy. I also write in Node, use TypeScript, right? I wrote this Cloud Function over here. This is running a TypeScript React app and pushing it out through Express. The Cloud Function REST API is written in Node. And then Aaron's a Python guy. He wrote the sentiment analyzer in Python, right? So he's got Python over here running in this Cloud Function. So versatility and the ability to be able to, use the right tool for the job, it's awesome.
Yeah, Cloud Functions can also handle code written in Go and Java, also Ruby. So if you've got developers on your team who, are comfortable in a specific lane, Cloud Functions can most likely give them something to work with where you can hook into these other technologies. You can take a Cloud Function, you can talk to BigQuery, you can talk to Vertex AI, you can talk to all the pieces of the Google ecosystem and get your tooling working together under the hood and, creating some efficiencies there in terms of cost and also resources. And this is another thing Promevo can help with as well. If you've got, for example, if you just have BI people on your team and they don't necessarily feel comfortable with the Cloud Run pieces, that's something that Promevo can do to help you integrate these functionalities across the pipeline.
All right. Well, I think that's it. That's just want to say that's super cool. I love seeing how you went from like chicken scratch on the back of a napkin to a fully baked designed app. That's super cool. But yeah, Aaron mentioned, Promevo does all of these things, and we help with the cloud side. We help you build, we help you scale. We can help with like user and like employee facing things like your workspace, your Looker dashboard. So reach out and say hello, and we're happy to talk things through with you. And of course, anytime you're welcome to reach out with any questions, anything you need help with. You can reply to any of our emails and we'll see it. So with that, thank you, Aaron. Thank you, Justin. Thank you, Carolina and Brandon on the Google side. Thanks for spending some time with Promevo today. And we will see everyone next time.